Hello, welcome back to Algebra. We're conquering the topic of solving systems of quadratic equations, also called solving quadratic systems. It's a short way of putting it. Last few lessons we talked about substitution. That's kind of your go-to technique. You're going to use that almost all the time, and you can use it for every quadratic system. We've talked about substitution techniques in great detail, but there is another technique called addition that we're going to use here. Now, if you remember back when we solved regular old linear equations, equations that involve lines, to find the intersection point, we can add the equations together. And we went through great discussions of why you're allowed to do that and how it works and so on. But the same technique that we used in the past for lines can be applied to these quadratic systems. But if you remember back to that technique, the way it worked is you have to add them together, and in the process of adding them, you can also multiply an equation by something and add it. But at the end of the day, when you add them together, one of the variables must be eliminated in order to let you solve for something. So you have to eliminate the variable when you add them together. So you're allowed to multiply equations by numbers, you're allowed to add them, but some sort of way at the end of that process you must eliminate one of the variables in order to solve for the other one and make any progress. If you can't eliminate a variable doing that, then you cannot use the method of addition. So what we're going to find out is that some of these equations you can't actually use this method because sometimes you cannot eliminate variables by adding equations together. So let's crawl before we can walk, and let's show the first one here and show how you can do it, and then we'll show some examples of when you can't. So what about x squared minus y is equal to 5? What about 2x plus y is equal to 3? Now, this system of equations might look similar. Actually, all of these problems and all of the problems in the next lessons, we've already solved them. We solved them by substitution. Now we're solving them again by addition. So what you might say, why are you doing the same problems? That doesn't help me. Well, it does, because when we learn a new technique with the same equations, it gives you some confidence that either technique you use is going to give you the same answer. So that's number one. And number two, the process is so different that you're going to get the same answer at the end, but the math in the middle is so different that it doesn't even matter that the problems are the same. So these equations we've already solved. We've already gotten the answers by substitution. Now we're going to use addition. So the first thing you do is you say, can I add these equations together and eliminate a variable? And the answer is you can. And let's see what happens. If you add the 2x squared to the 2x, you cannot directly add those because you have an x squared term and an x, but you can just say, and when you add these guys, you're going to get x squared plus 2x, right? Now when you add these guys together, you have a negative y plus a y, so these can be added together and it just gives you 0. So you don't have to write anything down here. On the right-hand side, you add these together and get an 8. Now you might say, well, that didn't really help me. I still have an x squared and an x, but you know how to solve these equations. x squared plus 2x, move the 8 over by subtraction, and then you factor and solve. You're never going to get away from having to factor things when you have quadratic equations like this. So you go ahead and open up your parentheses, and you say x times x is x squared. You can do 2 times 4 is 8, and the signs are going to work out like this. Negative 2x, positive 4x give you this, and the 2 times the 4 with a negative sign gives you negative 8. Okay? The biggest problem up until now that students make is they start getting confused when you add this to this. They try to actually add them together. 1 plus 2 equals 3. You can't do that because you cannot add x squared to x. They're different. So you just have to carry it through. But notice we did eliminate a variable. We eliminated y, and that's what I told you in the beginning. You must eliminate a variable, otherwise you cannot use this method. So here we now know that when we set this equal to 0, we're going to get x is equal to positive 2. When we set this equal to 0, we're going to get x is equal to negative 4. And then we have to plug these values in to any one of these original equations. It doesn't matter which one you pick. You can pick this one, you can pick this one. I'm just going to plug it into this one. So I'm going to rewrite this down. 2x plus y is equal to 3. So I'm going to substitute it in there. The value of x goes in here, so it's 2 times the 2, the value of x going in there, plus y is equal to 3. This is a 4. We move the 4 over, we're going to get a y is equal to negative 1, because 3 minus 4, you get a negative 1 there. We'll plug this into the same equation. 2x plus y is equal to 3. I do not have to use this equation. It's a solution, so the x values work in both, so I could plug it in there. It's the same thing, but let's just go ahead and put it into this one. 2 times x being negative 4 plus y is equal to 3, so we're going to get negative 8 plus y is 3, and we can add this over, so 3 plus 8 is going to be 11. Okay? Then you have two values of x that fell out, each one corresponding to a single value of y, so you have two solutions. The first x value was 2, comma, negative 1, because it goes with this y. And then the next one was negative 4, comma, 11, x, comma, y. Two solutions. So 2, comma, negative 1, negative 4, comma, 11. If you dig back into a few lessons ago when we solved these by substitution, the math in the middle looks different, but the answers are exactly the same. So either technique is fine. Substitution you can use all the time. There really is no case in which you can't use substitution. But addition, it requires the system to be able to eliminate a variable. Either straight away, we didn't have to actually do anything to eliminate because they just add to 0. But you're allowed to multiply these equations by whole numbers or fractions or whatever you want, as long as they're numbers, to put the coefficients such that you can cancel a variable, just like we did when we solved linear equations by addition. Now let me give you an example of something that you run into problems with. What if you have the equation x squared minus y squared is equal to 15? What if you have x plus y is equal to 1? This is the system of equations. Of course I can use substitution. We did that before. In fact, we solved this problem before. Solve for x, put it in here, or you could solve for y and put it in here. But let's say you want to add them together. So you start saying, okay, well, what if I add them? Well, I'm going to have an x squared plus an x. And you say, oh, this will cancel, but then it doesn't, because this is a y squared and a y. So you have x squared terms in one equation, but only x terms in the other equation. You have y squared terms in the first equation, but only y terms in the second equation. So no matter how you add them together, you cannot eliminate these variables because you can't even add them together. They're different exponents. You can multiply the equations by whole numbers, but that's not going to help you. If you multiply this by 2 or 1 or 3, you still cannot add these variables together because the exponents are the problem. So you're allowed to multiply by whole numbers, you're allowed to add them together, and there's no way you can eliminate a variable by doing that. So can't use addition. It does not mean there's no solution to this. It does not mean you cannot solve it. It does not mean you can't graph it. It does not mean you can't use substitution. It just means you can't use this method of addition. All right. Let me give you another one that runs into problems. So I have them on different pages, but let's just go ahead and let me actually figure out where it is. Yeah. Let me just show you here. I'm going to put both of the problem children in the same place. What if I give you the equations x plus y is equal to 6 and then xy is equal to 8? We solved this system of equations already by substitution. Let's say you want to add them together. You have the x plus this term, but it's xy. So you can't really add x plus xy. You can't really add y plus xy. Even if you multiply this by whole numbers, you're not supposed to multiply by variables, okay? You're supposed to multiply by whole numbers. You cannot really make it where I can eliminate those guys. So since you're sticking to the rules of multiplying by whole numbers and adding and so on and so forth, you really shouldn't use addition as a method to solve this guy. All right, so those are problems there. All right. Let's go ahead and solve one that does work. 2 times y squared plus 33x is equal to 33. I'm sorry, 3x is equal to 33. And then x plus 4y plus 7 is equal to 0. Okay? So this one works. Why? Because I have x terms and I have x terms. Now this is a y term and a y, so I cannot add them together, but I can add the x's together, so I can eliminate something. So let's tidy this up a little bit more. So let's tidy this up a little more and write 2y squared plus 3x is equal to 33. This one, we're going to write it with the y term first, 4y, the x term second, so I can put it under this guy here, is equal to 33. All right. Now, I cannot, I'm sorry, is equal to, I totally had a moment there. That's not correct. So you have a 7. Let's move this negative 7 on the right-hand side. You have 2y squared plus 3x, 33. Flip these terms around, move the 7 over to make it negative 7. Okay, now if we add these guys as they sit, 3x plus x is going to give me 4x, so that's not going to cancel. It's not going to eliminate a variable. So what I need to do is I need to multiply this equation by what? Not by 3, but by negative 3. Multiply by negative 3. And when I do that, I'm going to rewrite the system again. 2y squared plus 3x is 33. Multiply the negative 3 here becomes negative 12y Multiply the negative 3 here becomes negative 3x. Multiply the negative 3 becomes positive 21. All right, now you see you can add them. So I can add. And what happens is when I add these together, I can just write it down. I can't actually perform the addition. 2y squared minus 12y, because when I add it, I can't actually combine the variables together, but these add to 0. And on the right-hand side, you're going to get 54. 54. So now I can solve this guy. Let's move it over. 2y squared minus 12y, we'll subtract the 54, equal to 0. Now this polynomial is the same polynomial we got when we did it by substitution. So, from here on out, the solution process is the same, but we're going to go ahead and do it. We're going to factor out a 2 here just to make the factoring easier. Y squared minus 6y, 54 divided by 2, let me double check myself, 27 equals 0. The 2 is ultimately not going to matter at all. We can divide the 2 away. You'll divide by 2 and cancel, divide by 2 and you'll still have 0. So let's go ahead and just factor it as it sits. Y times y is y squared. 9 times 3 is 27. And the signs are going to work as minus plus. All right. Now we set this equal to 0 and this equal to 0. So we found that y is equal to 9 and y can be equal to negative 3. We set this equal to 0. And now we have to plug in. We can choose what equation to plug into. I can take these values of y and I can put them into here, or I can take the values of y and put them into here, but I don't like the squaring, so I'm just going to pick the second equation. And so what I'm going to get is I'm going to plug in to the bottom equation, which is x plus 4y plus 7 is equal to 0. I got to stick the value of y in here. So x plus 4 times 9 plus 7 is equal to 0. So x plus 9 times 4 is 36 plus 7 is equal to 0. X is equal to, let me just double check myself here, 43. Well, it's going to be 43, and when we move it to the other side, you're going to get negative 43 as an answer, negative 43. And then we're going to take this guy and we're going to plug in to the exact same equation. It's going to be x plus 4 times y, which is negative 3, plus 7 is equal to 0. So we have, this is going to be minus 12 plus 7 is equal to 0. And then x, this will be negative 5 equals 0. So then x is 5 by moving the 5 over to the right-hand side. So then for this value of y, I get this value of x. For this value of y, I get this value of x. And so I have two solutions. X is negative 43. Y is 9. X is 5. And y is, where's it at? Negative 3. These are the two solutions. Negative 43, comma 9, 5, comma negative 3. Same answers that we got when we solved this problem before. So when you look and try to decide if you're going to use addition or not, just see if I can multiply these by whole numbers, if I can allow one of the variables to cancel, and in this case, by lining it all up. That's the other thing. They put the variables out of order, so it's hard to see. So you need to write all the x terms and the y terms on top of each other so that you can see what you need to multiply by in order to have it cancel. All right, so let me just double check myself. Let's see here. Yeah, actually, I have one more problem left. It's not as long as this one, actually. So we're going to do that one next. It's going to be as follows. Y is equal to x squared, and x squared plus y squared is 12. Now, we've solved this one before. We did it by substitution. You can substitute in for the y, substitute in for the x squared if you want to. It's kind of begging to be solved by substitution, but you can use addition, so we're going to figure out how to do that. The first thing you need to do is write all the variables on top of each other. So the way I want to write this is move the x squared over, and it's going to be negative x squared. Then I'm going to add the y equals 0. Move this over, it makes negative x squared plus the y is 0. This I'm going to write underneath it as x squared plus y squared is 12. You see why I do it like this? Because then I can immediately see I'm going to add these, and I'm immediately going to get a cancellation. So I'm allowed to use this technique. This is going to add to give me 0, but then I'm going to have over here y squared plus y is equal to 12. Just add these together, add these together. Now I have to solve this by moving the 12 over. Minus 12 is 0, and then I factor. Y times y is y squared, and then 3 times 4 is 12. I'll double check myself. And the signs that are going to work is this. Negative 3y, positive 4 is going to give you the positive 1 there. And of course, this multiplies to give you the negative 12. So now what we have is y is equal to 3. We set that equal to 0. Set this equal to 0, we're going to get y is equal to negative 4. So we have two solutions. And now we're going to have to plug in. I can plug this into anything I want. I can put it into here or I can put it into here. But this one's just a much simpler equation. So I'm going to put it into here. Y is equal to x squared, but I'm going to write it as x squared is equal to y. Same exact thing. I flipped it around because I want to solve the value of x. So x squared is equal to 3. Put the value of y in. X is plus or minus the square root of 3. So x can be 3. Whoops, sorry, square root of 3. And x can be negative square root 3. And then I go and do the same thing here. I'm going to plug in x squared is equal to y. Now y is negative 4, so x squared is negative 4, and x is plus or minus the square root of negative 4. So this will give you an imaginary number. So this you just write down not real. So for each value of y that had negative 4, you would get plus or minus 2i, which is an imaginary number, right? So remember, when I said the coordinate turns out to be imaginary, you just throw that solution away. It's not a real number. It's not a physical crossing point. So you don't actually write any of this down in your answer. Even though this is real, it corresponds to an imaginary value of x. So there's only, in this case, two solutions, right? Two solutions. And the x value here is the square root of 3, and the y value came out to be positive 3. Negative square root of 3 was the other value of x, and positive 3 was the value of y. So that's the answer here. All right, so I hope you understand now how to do these, solving these systems of quadratic equations with the concept of addition. You need to find an equation to eliminate by addition or by multiplying by whole numbers and adding. And that's an example of what we did right here. We had to multiply the second equation by a number, in this case negative 3, so that it would cancel with what was above. And so what you have to do is arrange the terms so that you can quite easily see that. Once you add, you must eliminate a variable, and then you proceed throughout the solution as we have done. Now, I was cautious to tell you that you can always use the method of substitution, but you cannot always use the method of addition. I kind of fibbed a little bit there in the beginning. What most textbooks are going to tell you is that you can use the system of addition as long as you're multiplying the equations by whole numbers and adding them. So in this equation, we didn't have to multiply by anything. We just added them together and it all worked out. In this one over here, if we just add them, it doesn't work. So we have to multiply by a number. And then of course, this one over here, once we arranged everything, then we didn't have to multiply by a number. But typically your book is going to tell you multiply by a whole number, and then you can use the method of addition. But actually, this equation, for most equations, you can actually multiply by variables if you want to. And it works for the cases that I can show you here and test in front of, for these problems here, but I cannot guarantee you that it's going to work for all cases, because depending on what the equations are, you can run into extraneous roots and other things that become problems. But in some cases, you can multiply by something other than a number. So this was one that we did just a minute ago, and I told you really can't use the method of addition because it doesn't, you can't get these guys to cancel. You cannot add this to cancel, and you cannot add this, and you can't multiply by a number to make it work either. So typically you would just use substitution. I still think that's the best way forward. But in this case, notice if you multiply the first equation by the variable y, multiply this by y, it'll become xy. I'm sorry, multiply by, not by y, multiply by negative y. It'll become negative xy. This will become negative y squared. This will become negative 6y. So we multiply the first equation by negative y. Second equation remains unchanged. Then when we add it, this drops away to 0. This comes along for the ride, just adding 0 to it, and then this is a negative 6y plus 8. Now you have a quadratic in y, so then you can move the y terms over here, and you can factor, and you'll get 2 and 4 as solutions for y, and then you can take these two values and plug them into either one of the original equations, down here that you want. We'll choose this one, xy is equal to 8. When you put the 2 value in, you get a y value of an x value of 4, and when you put the 4 value in, you'll get an x value here of 2, so you get 4, 2 and 2, 4. When you go back and look at how we did this particular problem in substitution, this is the exact answer you get. So I kind of fibbed a little bit when I said you cannot use the method of addition unless you're multiplying only by numbers. Certainly for some equations it works. I cannot sit here and swear to you that it's going to work for every set of equations you have, because some equations can have singularities, meaning they go to infinity. Rational equations may get weird if they have fractions or radicals. It may be difficult for me to justify multiplying by variables like this, because when you multiply by a variable, you kind of are making assumptions about if the variable is well behaved or not. And so I don't want to get into all the theory. I'm just letting you know that for some simple ones like this, you can multiply by variables and get the things to cancel. But what I'd really like you to do is, if you can't multiply by whole numbers and get it to cancel, just use substitution method. I think that's the most straightforward path forward there. So make sure you understand all of these, solve these yourself. Feel free to do this on your own to make sure that it works when you actually multiply by the variable negative y up here. And then follow me on to the next lesson. We're going to wrap up the concept of solving quadratic systems by addition.